Um, well, the title's a little misleading because we did do another experiment where we got it to be steady state energy balance. At first, we didn't have enough data, and we were trying to do a transient balance, and it proved very difficult. And so we got more data, and my teammates were Mike and Mike, and we did this early October, and it was a car air conditioner. And there's two settings in a car. You can either do vent or recycled air, and our experiments were on the recycled air option, where it takes the air from the return and cycles it through. And those are the two vents we closed off. There's four vents in total. The two other ones you can close off completely, and these are the two that you can't at all. So that's the ones we obtained our data from. And we use anemometers, thermometers, and sling psychrometers. And the anemometers, we had two over the vents, and thermometers we had on the middle console, the back seat, and the anemometers also had thermometers programmed into them. And then we used the psychrometric charts for the enthalpies after finding the humidities. And the first day we did it, it was about 84 outside, and it was, I think that day it was partly cloudy. It had rained. It rained the next day, so it was, I think we had 84% humidity ambient, and the inside temperature, inside humidity was about the same. The second day was clear skies, and it was 95 degrees outside, and the humidity was 50%. This is it's a solar constant. It's from a .gov website, and it said about 480 BTUs per hour per square foot is how much sunlight heats up, but in perpendicular planes, such as the .gov website was from Middle California, which is about on line with us, and when it's perpendicular, it's about 70% maximum, and so it gets down to 320. That's if all the sunlight was converting to heat. And it also said that the metal in the car is negligible compared to how much heat gets through the glass. And so it's about the front window and back window, about 20 square feet of glass of sunlight coming in. And so it was about 6,400 BTUs per hour coming into the car. And so that's how much was coming in during the experiment. And that's not counting how much had been put in by the sun before we got there. And this was done about 1 o'clock, so it had been sitting out for however long Dr. Henry had been at school. And then we had the V is the velocity from the vents times the area of the vents themselves. And then we multiply that by the density, and we just did an average from the psychrometric charts, and got a density of air, since it was just recycled air from the car. And then we multiplied it by 60 to turn it into hours. The first one should be feet cubed per minute, because we had to multiply it by 60 to get to hours. And then we took that rate of air and multiplied it by the enthalpies we found, and to get the BTUs per hour. And then to convert it to tonnage, it's 12,000 BTUs per hour. And so it should be a Q prime. But the first day, and this may be error in our calculations, came out to be about 2/3 tonnage of air conditioning. And it should have been, the second day came out to more correct. It should be about 12,000 BTUs per hour, about 1 ton in a car air conditioning. And that may be because it wasn't as warm on the first day, but for whatever reason, it was still close. And the front seats, the highest point are the vents, and then the front and back seats stayed pretty constant, but the first blasts of air, the first few minutes, were the hot air being recycled into the compressor, started kicking in, and then after that it would get down much cooler than the inside of the car, and so that kind of shows that there is more heat being put in, since the front seats and back seats didn't go down to the same temperature as the vents, and so we kind of figured that's what the sunlight was doing. And that's the second day. It's just a little higher temperatures. It looked almost the same, except for the front and back seats weren't as equal as the first day. See, these are they almost get the same temperature, but on the second day, it was much harder to get the front and back seats to get to the same temperature. And like I said before, it's about 12,000 BTUs per hour, or 1 ton, in car air conditioning. And the data mostly fits, except for the first day. And the problems with that, maybe our temperature probes, and looking back, we probably should have used sunshade in the front and back windows during our experimenting to try to prevent as much sunlight as possible from heating up the car. And our temperature probes, the vents were on the dash, and so they were in direct sunlight, and so that may have influenced how much the temperature was actually coming out at.